Good. Welcome, everyone. I think we are now live. Let us know on Discord if everything go right. We have a little delay starting, but I think everything should be fine now. So off we go. Introduction to the blockchain. So to understand the blockchain, one needs to understand technology cycles. And I think one of the best books to talk about technology cycles is Innovator's Dilemma. It's an old book from the 90s that predicted a lot of things that happened, but most importantly, in a very clever way, explains how technology cycles work. So basically what you have is, and I would add maybe that the Steve Jobs had obsession about Innovator's Dilemma, and I being a young entrepreneur, had an obsession about Steve Jobs. So I couldn't resist to read the book. And what the book says, and this is in Steve Jobs' own words, is that technologies go through those cycles. They start in early springs, they have their summers, falls, and eventually they land on the graveyard of technology. And you can achieve so much more if you focus on those technology in their early springs and help them build adoption. There is so much more that you can achieve than focusing on those technologies that are already on saturated market. And I'll give you some examples. So smartphone, it's a very young technology. It's really just 15 years old. And I remember when smartphone revolution started, a lot of people were very skeptical, including myself. And I was like, yeah, the smartphone is cool, but my mother never gonna be able to use the smartphone. And yet, less than 15 years later, everybody owns one. It's even more popular than desktop computers these days. And there is a few funny things to note about the smartphones. One is that very first smartphone was created in Nokia. It was called Nokia Communicator. And the same smartphone revolution that they kind of started was the one that killed Nokia, because Nokia eventually was not able to transition to a smartphone from ordinary mobile phones, and eventually went bankrupt. So that's and that's not unusual. If you think about it, there is another disruptive technology that is a little bit older than smartphones. For example, digital camera. And some of you that are a little bit older might remember when the first digital camera showed up. The resolution was really low, and people didn't really treat digital camera as a serious thing. It was more like a toy, while the real stuff was created by serious companies like Kodak. But then, the irony is that the first digital camera was created in Kodak laboratories, and the Kodak would be a company that would eventually go bankrupt because they wouldn't sign up to a digital camera revolution soon enough. And so those are the starts. Those technologies, oftentimes, we call it disruptive technologies, oftentimes, initially, they don't make any sense. They are too much of a toy. So they don't feel serious. And when the smartphone show up, people would be like, yeah, this is a nice small computer, but how do I put my good old big spreadsheet on that computer, right? So, but those technologies evolve and getting better over time, and eventually they become part of our lives. And it goes so far that at some point they become sustainable technologies. They don't make sense anymore. Nobody cares anymore if they're getting better, right? So, for example, if I ask most of you what's the difference between iPhone 11 and 12, most of you wouldn't be able to tell me what really the difference is, or even 10 and 11 or 10 and 12. So it's funny that we don't care anymore. Like, the smartphones are just good enough. They're really good enough, and they're fine. And the same with digital camera. If I ask you what are the newest digital camera, how many megapixels they have, again, you probably wouldn't be able to tell me what are the current performance parameters, because they're just good enough. It's only when they grow and when the resolution is important, or the amount of feature, or the screen size is important, is when people get excited about all those technical parameters. Once they're good enough, they become sustainable. Every year you get a better iPhone. Every year you get a better camera, but we just don't care anymore. So when it comes to disruptive technologies, there is this chart. And if you look at the chart, there is this idea that they progress over time, and the progress can be different things, can mean very different things in many different contexts. So the progress might be, for example, amount of megapixels in digital cameras, or it might be the size of the screen or the speed of the processor inside a mobile phone, and so on and so forth, right? And what is important is at the beginning, when they start, they don't make a lot of sense. It takes a while for technology to improve and get better until they suddenly start making sense for the mass consumer market, right? So this is on this slide. This is visualized by this horizontal line, dotted line, first on the bottom, and they're getting better. And now is the time between the lower and upper horizontal line is the time where empires will fall and empires will be born. Empires will fall like Kodak or Nokia, and empires will rise to power like Apple, with smartphone revolution would drive them to become one of the most powerful, if not the most powerful company in the world. And the same could be argued for Google, that with Android would extend their search business to become from a very powerful company into one of the most powerful companies in the world. And or the same could be argued about Canon, that was not so known before the camera revolution and so on. And as the technology progressed, they got to a point that they are more than good enough for the average customer. They're just fine. I don't care anymore about what is the new iPhone, what is the new camera. So when you look at the blockchain, it's important to understand it's a disruptive technology. If we were to look at where it is on this progression line, on this performance, it's still very early. It's still somewhere. It only just now starting to make sense for the mass consumer, which is also a lot of progress, because I kind of doing this presentation, different variants of this presentation for almost 4 years, and there is a huge progress, because 4 years ago it didn't make any sense for anyone. It was just a new tech, new tool, new toy to play with, and now finally 4 years later, we see it's starting to make a lot of sense for a lot of people, but there is still some way to go to make for it to make sense to my mother, let's say, or father, or less tech savvy people, less interested in investments and financials and advanced technologies. So if we summarize this idea of disruptive technologies, like they often come, and by many factors they feel lacking, they feel unideal, it doesn't feel good, but they have a new property that allows to build new things that's gonna transform the industries, that's gonna make that empire will fall, empire will rise to power. And for smartphones, the thing is that smartphone is super handy. It has a camera and GPS, so you can build Instagram, you can build Uber. Another example would be the internet, right? Very early internet didn't show a lot of promise. We have a dot-com bubble. People would buy. The dot-com bubble would be very similar to bubble we have with the cryptocurrencies right now. And a lot of people would be like, yeah, the internet, it has no future, and so on and so forth. And probably most of you don't remember that anymore, but there was a bubble burst in early 1999. And in early 2000s, a lot of people would say that internet is overrated and it doesn't make a lot of sense. But internet, the whole business model in internet doesn't make sense because it's not physical. But that was not the important thing. The important thing was that with the internet, you have instant access to information. So you can build things like Amazon and Netflix, and you could efficiently optimize the retail market, or you can optimize the TV market, and many others as well. So when it comes to crypto, they seem to be lacking in many ways. So the transactions are kind of expensive, and the throughput is not very high. And like if you compare it with Visa or MasterCard, everybody says, yeah, it's Visa have 3,000 transactions per second or whatever. But they have a new feature that was never ever that never ever existed before. And the feature is trust. With this new property trust, you can build things like you couldn't build before. And a great example could be money. You can build money. You could never ever build money on your own without blockchain. And you can build digital gold. You can build new financial system, things you could never ever build before. So let's take a look what it means. Yeah. So let's start here. Well, actually, let's go back. So what is blockchain anyway? Well, you can think about blockchain as basically a giant spreadsheet. It's going to be a little bit simplification, but it's fine for now. You're going to learn much more during the workshops later today and tomorrow. So you can think about it as a giant spreadsheet. And the spreadsheet really, we're going to start with just 3 columns. There are 3 columns: from, to, and value. And each column just represents and say, hey, the guy from is sending the money to the guy to, and the amount of money being sent is value. But this spreadsheet has an interesting properties. So there is no admin access. Nobody can edit the history. Nobody can change the rows that was already created. And there are some rules. There are some rules that say I cannot transfer more than I have, or I cannot transfer what I have twice, or to put it in a more general sense, the amount of money that I have that I transfer going to be subtracted from my account and added to another person's account. And by the way, I can only spend my money. I cannot do transfer to things that I don't know. And this very simple. So we can really think about blockchain as a very slow distributed database, open to anyone with no admin access. And with that, you can build a really interesting field like digital gold. So why does gold has a value? It seems that throughout the history of the human civilization, the value would be defined by scarcity. So a long time ago, there would be rice stones, and the rice stones would be just the stones, the really big stones in the place called rye. And people would transfer money, people would have the notion of money by owning the stones. And everybody in the village would know which stones belong to whom. And you could even split the stone and say the top half belongs to this guy and the bottom half belongs to that guy. But the thing is, it was super difficult to create a new stone. So therefore the value would be carried in time. And the same thing happened over and over in the history of the humankind, with the seashells and all kinds of different things that are being rare and difficult to mine, difficult to possess. And from all those things, throughout the centuries or even maybe millennials, the gold would be the most value carrying thing ever. And the reason is that the gold is really difficult to mine. There is very limited amount of gold in the world, and there is very limited access to mining new gold. And as the technology progresses and we mine gold faster and better, more efficiently, the amount of gold left to be mined is less and less. Therefore, the value it's getting harder and harder. We're getting better and better. So the steady flow of gold is very similar throughout the centuries. And the funny thing is, gold holds value so well that you could buy for similar amount of gold today and 300, 400 years ago in London. If you go to a restaurant, you can buy a meal and a drink for similar amount of money, similar amount of gold, really. And here comes the Bitcoin. The idea of the Bitcoin is that we use blockchain to create a limited supply money, or some people think about it as really digital gold. And there is no easy way to produce more Bitcoin that already is. And actually more than 80% of Bitcoin that will ever be created is already created. So we still have this small flow of money coming in. But the point is that we know that the flow is decreasing, and even if you look at the stock to flow ratio, so how much stock there is, how much already exists in circulation versus how much we can add, you see that Bitcoin is already by many standards very close to gold, much closer than any currency or any other, or really any other precious metal. But because the flow of Bitcoin is steadily decreasing, we see that in just a few years, the flow of Bitcoin into the existing stock gonna be the best by far versus any other currency, versus any other asset that exists in the world. Therefore, a lot of people believe that Bitcoin gonna be the gold in the future, and they're gonna only raise in value in time. And today we ain't gonna, this is probably one of the last times you're gonna hear about Bitcoin today and tomorrow. But I think the important thing to realize is also that Ethereum is going to, through this hard fork later this year, initially scheduled for July, that will actually not only limit the amount of Ether being produced, but also gonna burn some of the already existing Ether, therefore trying to push even further what's possible with Bitcoin, and push and allow to have a money that is growing in value over time. Now, and just if you look at the Bitcoin rainbow, it's called a rainbow chart. I ain't gonna go into details how it is calculated, but the important thing, it's a logarithmic scale. If you look at the value of Bitcoin over time, you see that in the long run it's growing, even though locally it might lose a lot of value. Now, the last thing I want to talk about is smart contracts. So you're gonna learn a lot much more about smart contracts today and tomorrow, but I want to give you a very simple intuition what the smart contracts are to start with. So imagine, coming back to our spreadsheet analogy, imagine now that we have this giant spreadsheet with all those rules, and we can put a macro, we can create a smart contract, a small piece of code that we embed into a spreadsheet. And we do it by just sending transaction to nobody. So we can send a little bit of Ether to anyone, or we can just send a piece of code to the blockchain. This piece of code gonna be put there on the blockchain, and it's gonna have its own address. So you're gonna have a new kind of animal living in our blockchain jungle. So we have wallets, and as you might already know, or you will learn soon, wallets have an address. There is a private key, so there is a the person who owns a private key can move the money around, can decide what to do with the balance. And the balance is, let's say, in Ether in case of Ethereum, and it's a cryptocurrency. But there is this new animal now called contracts or smart contracts. And those are programs, and they live on the blockchain, and they can execute the code. So now we can send money from person to person, from address to address, or we can send money to a contract, or contract can send money to us, or contract can send money to contract. And these contracts, by the way, they are Turing complete. So for those of you who graduated computer science, you know that you can build with those contracts pretty much any program that you can build with any other programming language. And they are deterministic. So the contract will always give the same result no matter on what computer it is run on. And I can send a transaction to a contract, and the transaction can just increase the balance of the contract, but it also, I can request the contract to do something for me. So I can call a function the contract. So the contract can do some computations, and based on those computations, perform some actions, again, probably transferring some money somewhere. And for those executions, I need to pay with gas. And gas, I buy with Ether. So essentially, I pay with Ether for the execution. So there is the whole thing when every single execution of the smart contract needs to be paid for. And with smart contracts, I can build a lot of interesting stuff. And one example is tokens. With smart contracts, I can build new cryptocurrencies. So I can build a smart contract that creates a lightweight cryptocurrency. So it is not a new blockchain. It doesn't need the miners. It can utilize existing Ethereum infrastructure. and you can use Ethereum wallet to manage all your ERC20 tokens and Ether. So this is very powerful notion, because now anyone can create their own thing, their own cryptocurrency, without having cryptographers, networks experts, and so on and so forth. They just need to have a very basic knowledge about how to build smart contracts. And tomorrow you will learn how to write. Well, today you're gonna learn more about Ethereum and very basic smart contracts, and tomorrow you will learn to build your own ERC20 tokens. Now when it comes, give me just a second here. I think we're getting pretty close to the end. So yeah, I think that was pretty much the last slide for today. What I wanna say is that you can build many other things with smart contracts. You can build exchanges, you can build new financial instruments, and people did do that. And there's the whole DeFi space, there's the whole NFT space. There's huge some industries that holds and moves around billions and billions of dollars built with smart contracts on Ethereum. And all about it, you're gonna learn in the following presentation. Well, not all about it, but quite a lot about it. You're gonna learn in the next presentation from Bartek Rutkowski, who is going to join us just in 2 minutes. For now, that's it from me for today. And yeah, enjoy the next workshops, and thank you very much for listening.